Right, good morning, Year 7. So what we're going to do today is we're going to just quickly finish our work on electromagnets, and then we are going to sort of review the topic. So last lesson you identified how you get an electromagnet and you watched the video. First question though to you, does an electromagnet have a magnetic field? Well, the short answer to that is yes, it does. Okay, when you create an electromagnet, you wrap a coil of wire around a magnetic material like iron, and that turns the iron into a magnet with its traditional shaped magnetic field around it, which you learned from a few lessons ago. Okay, so does an electromagnet have a magnetic field? Yes, it does. Okay, and that is the shape of it. And just in case you can't remember, you could always quickly redo that. Okay, so the first task I would like to do is pause the video on these three statements, and I would like you to correct them, and not just correct them, but explain why they are now correct, okay, or what correction you've made. So, for example, these are your three statements. A bar magnet is made up of a coil of wire, a power source, and a core. Okay, why is that wrong? So make the correction and then just put like a little footnote what the correction was and why you made it. Okay, so pause the video, write down the correct statement. These statements are all wrong. Okay, off you go. Okay, welcome back. Now, what you should have had for this first one says a bar magnet is made up of a coil of wire, a power source, and a core. It should be an electromagnet is made up of a coil of wire, a power source, and a core. Okay, so a bar magnet is a permanent magnet that you looked at the beginning of the unit. An electromagnet is what you looked at last week and how to make. Wood makes a good core. Right, that would be wrong. It should be steel or iron makes a good core, preferably iron. The reason for that, wood is not magnetic. Okay, so that would be your footnote. And then finally, an electromagnet is a permanent magnet. That's wrong. An electromagnet is a temporary magnet. Okay, because if you turn off the electricity, you turn off the magnet. Okay, so you can turn it on and off like a switch. Okay, so last week I asked you to draw out an electromagnet. Just in case you didn't get one, okay, you can quickly pause the video and draw it now at this point. Okay, so you should have a battery or cell connected up to a wire. That wire coils round and back to complete the circuit, and it coils round an iron core, in this case just showing using a plain nail as an iron core. Okay, so if you didn't get that last week, you should have that. So if you didn't, pause the video now. If you did, just moving on. So what is the link between electricity and magnetism? Right, now this is one of the fundamental laws of nature, and not many people understand this, so don't worry if you don't quite get it in Year 7. But wherever you get electricity, you have a small magnetic field. And if you were to hold a very small compass next to a wire which has got a strong current flowing through it, your needle would point towards it, just like it's attracted to a magnet. Okay. Now, the other thing is, you can actually produce electricity from magnetism. In fact, later on, you'll learn that essentially a generator is a magnet that spins around a coil of wires to create electricity. It's a giant magnet spinning to create electricity. So here's the thing. Electricity creates a magnetic field, but a magnetic field can also generate electricity. The two are fundamentally linked. Okay, so pause the video and then you can actually write something like that now. So it would be, explain the link between electricity and magnetism. So whenever you get an electric current, you also get a magnetic field, when can generate electricity from a magnet actually. Just from a magnet. Right, so there is your answer. So pause the video and copy that into your book. So whenever you get an electric current, you also get a magnetic field. However, you can generate electricity from a magnet. The actual mechanism I won't teach you today, but you get the idea. Okay, so pause the video and do that now, please. Okay, welcome back. So key things to remember, it's not the wire that matters, it's the current. So as long as you've got a flow of electricity, you will have a magnetic field. It's not the wire so much, it's the flow of electricity. It's the electricity flowing through it. If there is moving electricity, you'll have a magnetic field. So a magnet, since electricity generally moves through wires, that's where you get the magnetic field. A magnetic field is produced around the coil of wires. Well, just going back to earlier slide, we know that. There it is. There's our magnetic field. And finally, and this is a really one that people don't get, most wires are made of copper. Is copper a magnetic material? Well, it is a metal, but it's not magnetic. But because electricity flows very well through copper, you would have a magnetic field around a copper wire, okay, even though copper itself is not magnetic. So, if you wanted to, you can very quickly add these notes to your, well, although they're not hugely important. Possibly this last one is quite important. Copper isn't a magnetic material, and yet, if electricity is flowing through it, it would have a magnetic field around it. Weird, but true. Okay, so this is an example of how we use an electromagnet. This is like a bell, a bit like a school bell. And I'm going to explain to you how it works. You'll need to copy up this diagram, and then you can just bullet point the key points of how it works. So, firstly, you've got your battery here, you've got a switch, and you've got your wires. So the electric current goes through the wires, and there's your coil. And then the electric current would seem to go through this metal bit here, which is the hammer, and it looks like there's a hinge, so it probably connect there, and then back round to complete the circuit. So there's our iron core, and there's the hammer striking the bell. So how does this work? Right, so what happens is when the electric current is on, okay, this part would actually connect there to complete the circuit. So think of that as sort of just swinging back that way. So those two bits there would be touching. So if we can do that, the electric current will flow through the wires, through there, all the way around to complete the circuit. So there's electricity flowing through this thing. When that happens, this becomes an electromagnet because the electricity is flowing through these wires. It becomes an electromagnet. The hammer would be made of metal, particularly iron or steel. So it would pull away and essentially, be attracted like this. It would be pulled towards the magnet and go bing and bong the bell. Okay, so it goes bing, bongs the bell. But then, of course, it's not touching here. So the circuit is broken. So there's no electricity flowing. So what happens is, if there's no electricity flowing, this is no longer a magnet. And so it kind of swings back, but as it does, it touches this again, completes the circuit, the current flows, and it gets attracted, bing, again to the electromagnet. And so that's why you get a bing, 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 that kind of effect on an electric bell. It's very clever design. So what you need to do is copy this up and in your own words, try and explain this. Now, this will probably take you a few minutes to, well, about a minute or two to draw, but actually thinking about how it works is going to take some explanation. So once more, let's just go through it and you can pause the video as you need. So normally, what would happen is this would be connected up. Oops. This would be connected up like that. I just want to move. Sorry about this. Okay, so what we would have is a circuit with an electromagnet, the hammer. I can actually label a few of these things for you. So that's the, let's make that a bit smaller. Hammer. That's the bell. The electromagnet. Wire or battery, I suppose. You can draw all this up in your own time. Okay, and what happens is this would be connected up there. The electric current would flow, creating an electromagnet. The hammer would be pulled towards the pole of the electromagnet, and in doing so, striking the bell. However, that breaks the circuit at this point, so the electricity can't flow. Therefore, this is no longer an electromagnet, and this swings back to its original position. But in doing so, it reconnects the circuit, the electricity flows again, this becomes an electromagnet again, and once more, it's attracted and it strikes the bell. Okay, so it's a step-by-step process. You need to explain that in your own words. So drawing this will probably just take a couple of minutes. Explaining it in a code and a sort of in a way that makes sense will probably take about 5 minutes. So once again, pause the video and do that now, please. Okay, welcome back. So this was the practical that we were going to do in class, and these are a section of the results. However, because you haven't got any graph paper and you probably haven't got the equipment you need to make an electromagnet, we're not going to do this. I'm just going to show you the key principle of what this was designed to show you. So you could probably identify, here we've got the number of coils. So thinking about our electromagnets, what would happen to the strength of the electromagnet if we increase the number of coils? Well, the experiment was how many like paper clips or tacks could you pick up? Okay, the more paper clips you could pick up, the stronger the electromagnet would be. So essentially, the key pattern that you need to know is this. Okay, so I'll get you to draw this out in a moment. Okay, but we're not actually going to do the experiment. So this is so the thing we changed, that was, let's just say, number of coils. Okay, and we could start like here and 0. So let's just say we could wrap our wire around up to 40 times. Okay, how many paper clips could we pick up? Okay, so we go number. And of course, the more paper clips we can pick up, the greater the strength of the electromagnet. Okay, and again, it could be sort of the numbers you would have expected to see would have been like this, so maybe 25. Probably need to make that slightly different, so maybe. Okay. The numbers you probably would have got would have been something like this. Now, what we would have found, you can just use this as an example, was that, okay, the more coils we had, the more paper clips we could pick up. So the strength of the electromagnet would have increased. However, you'll notice that the line is straight. It doesn't say, if we just say it goes up, that's not good enough because that goes up. It's a completely different line. No, the word we would use is there is a direct link, or to be more precise, it is directly proportional. Now, what that means is, as the number of coils goes up by a certain amount, the strength of the electromagnet, or the number of tacks picked up, goes up by the same amount each time. And so we get a completely straight line. Okay? So, can you pause the video and just draw that in and just explain what that means? So, as the number of coils goes up, the strength of the electromagnet goes up by the same amount each time. Okay, pause the video and do that now, please. Okay, welcome back. Now, you may think the graph hasn't changed. Look closely, the graph has changed. Now, what I've done is I've increased the current. Now, what I would do is basically add more batteries to our circuit. So, as I've increased the current, so basically the more electricity I have flowing through my wires, the stronger the electromagnet is, because look, the more paper clips I can pick up. And once again, same thing, it is directly proportional. Okay, so basically increasing the number of coils or increasing the current increases the strength of your electromagnet, and the pattern is this straight line. So as the current goes up, the strength of the electromagnet goes up by the same amount each time. Okay, so once again, pause the video quickly and draw this in with like one sentence to explain it. Okay, so next week it's the end of topic test, because we've done all our lessons now on magnets. So I'd want to spend the last sort of 20 minutes or so of the lesson just revising, going back through your book, the material that you've done this term on magnets. So magnetic materials, how you create magnets, north and south poles, magnetic fields, and electromagnets. Okay, so just spend a few minutes, well, 20 minutes or so now revising. Probably a good idea to do it a bit before as well next week. Then in the lesson there'll be the test. It won't be a massive one, probably just about half an hour or so, and then I will try and give you the answers at the end of the lesson. We'll mark it, quick feedback, just to see how you're getting on. So year 7, good luck with that, and I will see you all next week. And of course, if you get stuck today, I'll be online to answer your questions. Okay, good luck, take care.